Hello dear students, welcome back. Today we are going to discuss about absolute and conditionally convergent, and then after we will discuss about the power series. So let us first start with the absolute and conditionally convergent. So one, we can say that the given series is the absolute convergence. So absolute, that is clear that if the series of the absolute value, whatever we have the series of the absolute is the convergent, then definitely we can say that the given series is the absolute convergent. When we consider the series is the conditionally convergent, so if the series, whatever we have given, the series is the convergent, but its absolute value of the series, that means whenever we assume that the sequence with the absolute value, and when we assume that it's series, and if we get the divergent, then we can say that the series is known as the conditionally convergent. So if the series UN is absolute convergent, then definitely we can say that the series will be the convergent. So what does it mean? If series is absolute convergent, then simply we can say that the series is the convergent. If the convergent series is a positive term series, then it is absolute convergence. So keep in mind that if convergent series is a positive term series, the given series is only positive term series, then definitely it will be the absolute convergence. This is the first question. Determine absolute or conditionally convergence of the series. So this is what exactly summation starting from 1 to infinite minus 1 raised to n square divided by n cube plus 1. So this is our un, so also you can take its absolute value. So this is n square divided by n cube plus 1. Now what you have to do, here we want to show that the given series is absolute convergent or not, and for that what you have to do, you have to start with its absolute value. So we have assumed that, and from this what we can determine, that is Vn. Also for our simplicity, you may assume that the modulus Vn. So highest power from this one numerator, that is n square, and the denominator contains highest power, that is the n cube, and so from this what we can say 1 by n, and that will be the what our Vn. So now we applying the limit comparison test. Limit n tends to infinite mod of un divided by Vn, and after that numerator, that is un is there, and that is given n square divided by n cube plus 1, and divide by Vn is there, that is 1 divided by n. But it is clear that n raised to cube contains a numerator, and the denominator also we can take n cube common, and it will be the cancel out, and you will have 1 divided by 1 plus 1 divided by n cube. Now if we take the limit n tends to infinite, so 1 divided by 1 plus 0, and that is 1, and this is non-zero and finite quantity, and hence we can say that according to the limit comparison test, the series may be divergent or convergence together. But we have to decide that which one series, whatever we have the given series, is convergent or divergent. So for that we have to concentrate on the denominator series. So yes, series, but series Vn is what? That is 1 by n, and according to the P series Vn is going to be the divergent, and hence we can say that the above series, that means from this whatever we are going to assuming that this series is going to be the divergent by the comparison test. So what we have derived series, if I say this is the series un, but we have derived that absolute value of un is divergent, so now you can observe that the absolute value of un is the divergent, then the absolute convergent is not there. But what about the conditional? For that, what says conditionally convergent says that the series must be divergent, and second thing says that if the whatever the series is what exactly convergent. But according to first condition it is there, and what I want to show that the second condition should be the convergent. So your terms are what exactly alternate terms are there, therefore we can say that alternating series is there. That means I have to use that the alternating series test, and for that we have two conditions. So first one condition says that absolute value of that it should be what? Exactly decreasing. And second condition says that limit of the nth term, and that should be what? Exactly, that is 0. So for the sequence is increasing or decreasing, so for our simplicity I'm just going to assume that un minus absolute value of un plus 1. This is un, just n is replaced by n plus 1, and after that whenever you apply the LCM and when you simplify, so you will left with this one, and therefore you will get the given number is nothing but greater than 0, because for any choice of n you will see, and therefore we can say that this sequence is the decreasing sequence. Also you can see that un is equal, that is n square divided by n cube plus 1. How we can say that this is a sequence is the decreasing? So in that case, first find its derivative and then it will be the more clear. First denominator square. Denominator is there, derivative of the numerator, that is 2n. Numerator is there, derivative of the denominator, and that is 3n square. So what you are going to get? 2 times n raised to 4 plus 2n minus 3 times n raised to 4 divided by n cube plus 1 raised to power 2. So from this you can observe that this is minus n raised to 4 plus 2n divided by n cube plus 1 raised to power, that is 2. But when you assume that n is equal to, so what you are going to get? So let us first take n common. So you will get 2 minus n raised to cube and divide by n cube plus 1 raised to power 2. But when you put your n is equal to, if you put n is equal 3 for your simplicity, so what it will be? So it is clear that 2 minus, that is 27, so it is going to be the negative, and therefore we can say that the sequence un is nothing but decreasing. And if you like this one, so also you can carry on. Now let us focus on the second condition. Limit n tends to infinite absolute value of un, but un is nothing but n square divided by n cube plus 1. But numerator contains highest power, that is n square is there. Denominator contains highest power, that is n cube is there. But when you simplify, so you will left with 1 divided by n into 1 plus 1 divided by n raised to cube. But when you take the limit, so 1 divided by infinite, and that is going to be the 0, and therefore all the conditions of the Leibniz test are satisfied, and therefore we can say that the given series, whatever it is a convergent, and therefore the series given is convergent and its absolute value is the divergent. Therefore we can say that the given series is the conditionally convergent. This is another question. Determine whether the series cosine divided by n square is convergent or divergent. But here it is clear that cos function is bounded by 1. But when we assume that its absolute value, so totally we can say that this is less or equal 1 divided by n square, and this is un. Let us take this is vn. So let vn is equal summation 1 divided by n square is there, and from the p series test we can say that the given series is nothing but convergent. Therefore we can say that by comparison test the given series un is also convergent, and therefore series un will be the absolute convergent, and therefore by the given theorem whatever we have recently done, that if the series is absolute convergent, then definitely we can say that the given series is convergent. Now we have the power series, a series of the form an into x minus a raised to power n starting from 0 to infinite. But when you put n is equal 0, so it is going to be first term a0, then a1 n is equal 1, so a1 into x minus 1 plus a2 x minus a square plus and so on. So this is nothing but power series, and this is power series in power of x minus a, or you can say power series centered at a and power series about the point x is equal a. So simple, you can say that this is the power series about x is equal a, or you can say power series centered at x is equal a. Also you can say this is a power series in terms of x minus a. Your x is a variable and an is a constant, is called coefficient of the series. And let us see this question, summation starting from 0 to infinite, x raised to n divided by n factorial. When you expand it, so this is exactly our the power series, but it is in power of x centered at, if I say this is centered at x0 is equal a is equal, that is the 0. But here x0, that is our a is nothing but here x0. So I can say x0 is equal, a is equal, that is 0, therefore centered at origin. So let us see first question. Now how we can say that the given power series is convergent or divergent? So let us see first test the convergence of the series, and then it will be more clear. So here un is equal, so from this you have to write the first general term. So 1 can be written as, that is x raised to 0, x raised to 1, x square plus x cube, and so on. So in general you can write first nth term, that is x raised to n, because power contains difference is 1, and therefore I just represent n. But if I put n is equal 1, so it is going to be the x second term. But I want here first term, that is x raised to 0. So what I have to do, just I have to write n minus 1. But if I put here n is equal 1, so it is going to be x raised to 0, and that is going to be the 1. Divide by first term 1, 4, 7. That means the difference is nothing but 3. So I write that is the 3n. But we want here n is equal 1, so it should be 1. So n is equal 1, so it is going to be the only 3. But I have to subtract by 2, and so we will get the first general term for this one, and I want here general term for the second terms, that is 2, 5, 8. So what it will be, the difference is that is 3, and so I can say 3n. But if I put n is equal 1, so it is going to be 3, but I want 2, that means I have to write here subtract by 1. And then we have 3, 6 and 9, so difference is 3, so I just write 3n. But when you supposed to put n is equal 1, so it is 3, and that is we have n is equal 2, so we have 6, 9 and so on. And this is going to be what exactly your nth term. So using this we can determine un plus 1, and now we are going to apply here the ratio test. Also you can say that the D'Alembert ratio test. So un divided by un plus 1. So whenever you say this is a un and this is divided by un plus 1, so this can be written as in this way. But numerator contains, that is x raised to n into x raised to minus 1, but x raised to n will be the cancel out, and you will left with x raised to minus 1, but that can be written as, that is 1 by x. Now just take n common from here, n common, so you will left with n raised to cube. And here you will have n common, again n common, again n common, so you will get n raised to cube is there, n raised to cube, that will be the cancel out. And when you apply the limit, so it will be what, that is you will get 1 divided by x. But according to the D'Alembert test, the series is what exactly convergent. When we can say that the series is convergent? So whenever you have the 1 divided by x is greater than 1. So let us first recall a ratio test. Actually we have seen that this series is the positive term series, and if we supposed to find its limit, and if we get the answer L, then definitely we can say that this series is what exactly convergent. L greater than 1, then the series an is the divergent, and L is equal 1, that means test is failed. But we have here just assumed that if I assume that reciprocal of this one, so in that case what it will be, limit n tends to infinite, absolute value of n divided by n plus 1, and suppose that you have the answer L. First condition, that L is greater than 1, then the series n is going to be the convergent, and if you get L is less than 1, then the series n is going to be the divergent, and if you get L is equal 1, the test is failed. And that you should keep in mind. So this one also you can apply this one, but we have here just assumed that this one, and I have just noted that the L is nothing but 1 by x, and when we can say this series is convergent, if this quantity is greater than 1. So this quantity, if it is greater than 1, then we can say that the series is convergent. But when we assume that it's reciprocal, so it is going to be the x is less than 1, but x is always greater than 0 because the given question says that x is positive, and therefore the series is convergent if we have this one, and divergent if we get this quantity is the less than 1, and therefore when we take its reciprocal, so it is going to be x greater than 1, and if test is failed, if we have the 1 divided by x is equal 1, that means we can say x is equal 1. But what we can say, but x is equal 1, then the series will be this one. But again, numerator contains that is highest power n raised to 0, but when you expand this one, so denominator also contains that is the highest power, that is n raised to cube. That means we can apply here the comparison test, and therefore Vn, that is 1 divided by n into n, that is n cube. So 1 divided by n cube is there. Now you have to apply the limit comparison test. Limit n tends to infinite un divided by Vn, and n raised to cube is going to be cancelled out, but when you take, so you will get the finite and non-zero quantity, and therefore we can say that both the series un and Vn are convergent or divergent together, but the denominator series, but this series is convergent with the p series test, and therefore we can say that by limit comparison test, whatever we have the numerator, and that series is also going to be the convergent for x is equal 1. So conclusion says that the given series is convergent for 0 less than x less or equal 1, and divergent for x is greater than 1. Let us understand one more question. Test the convergence of the series. So power contain n is there. That means we have to consider here root test. So let us apply un raised to 1 by n to this nth term. So what I'm just going to left with n plus 1 divided by n plus 2 into x. But when we take n common, because this power n is contains the highest power, that is n raised to 1, and denominator contains the same, that is n raised to 1, and we can take common and get cancel out, so you will left with this. And when you apply the limit n tends to infinite, so what you will get 1 plus 0 divided by 1 plus 0 into x, so you will get only x. But root test is there, so let us recall that first root test. So whenever we have given that this series, and if we suppose to get un raised to 1 by n, and if I take limit n tends to infinite, and if you get the answer L, so first condition says that 0 less than L less than 1, then the series n is convergent, and if you get L greater than 1, then the series n is the divergent, and L is equal 1, then the test is failed. So according to this, what we are going to left with only x. That means this x is less than 1, then the series is going to be the convergent. So therefore for the 0 less than x less than 1, because given condition is what exactly x greater than 0, so therefore 0 less than x is less than 1, so series will be the convergent, and x greater than 1, the series will be the divergent. But x is equal 1, then the test is going to be failed. That means further investigation is required. So let us first put here x is equal 1, so we will have un is equal this one. So based on that also we have seen that whenever numerator as well as the denominator contain the same power, so we will use the zero test, and it is called for the divergent test. So what we can say, n raised to n, otherwise you may write n raised to n common and get cancelled out, so 1 plus 1 by n divided by 1 plus 2 divided by n raised to n, and also this can be written as this way. And when we apply the limit, so 1 by n has a reciprocal, that is n, so as a power is there, so we can say this quantity is going to be the e. And what about here? Here it is not there, so I have to divide by 2, so I have to ultimately do power 2. So whenever you simplify, so it will be the same. So 2 by n has a reciprocal, that is n by 2 as a power, so this quantity is going to be e, and e raised to power 2 is there. So whenever you simplify, so you will get 1 divided by e, and that is non-zero quantity, and hence according to the zero test we can say that the given series is divergent. So for x is equal 1, so it is going to be the divergent. So in conclusion, so we can conclude proved that 0 less than x less than 1, then the series is convergent, and the divergence for x greater than 1, but also we have seen that when x is equal 1, the series is the divergent. So I have added equalities there. So in this video we have discussed about the absolute convergence, conditionally convergence, and then the power series, and based on the example. Thank you.